I think we can start, Ruth, if you want to give people a thumbnail of why we did this. And
now that I can talk, that I just unmuted. Thank you everyone for coming. We really appreciate it. We are very fortunate this evening to have a presentation on deep water injection wells from somebody who is involved in this in a day-to-day situation and can give us much greater insight. Of course, we've all been curious as to how this is going to come together at our own Manatee County Piney Point facility. And I know a number of us have some concerns or curiosity about how that's going to come together. So Barbara, if you'd be kind enough to introduce Jesse, I'd appreciate it.
Sure. It's my pleasure to introduce Jesse Ehren, who is currently Director of Water Treatment for Bosque Disposal Systems in Fort Worth, Texas. But he is a native Floridian with a master's degree in planning from FSU, where he focused on natural resource management. He is a conservationist by training and passion, and for over 10 years, his career has focused on promoting conservation of the fresh water used in the oil and gas industry. And to date, Bosque Systems, his company, has conserved close to 1 billion gallons of water. Wow. So Jesse has been a leader in advocating for the new standard of environmental stewardship for his industry. And he has also served as a subject matter expert across many states in developing deep water disposal wells with lots of experience in this area. So Jesse, take it away.
Thank you for the introduction. I appreciate everybody's time. I'm going to share my screen here, and I want to make sure we have enough time for questions. So we'll get right into it. Can everybody see the presentation? All
Yes.
right, good. So obviously today we'll be talking about deep water injection wells. I'm going to try to get through the first couple sections concerning the regulatory realm quickly. It's material, but it's kind of in the background. And then really we're going to focus on the safeguards as they relate to injection wells and facilities. So to start off, we'll get into the classifications of injection wells. There are 6 classes. Today, we're going to focus on only class 1 injection wells. Those are used to inject hazardous and non-hazardous fluids into deep isolated rock formations. It's also the classification that Piney Point falls under. So that's what we'll discuss today, pretty much exclusively. Class 2 wells are what the bulk of my experience is in because they're exclusively associated with oil and gas. So this slide, I put it together and it's a little bit misleading. I want the 2 takeaways from this slide. Takeaway 1 would be the EPA has established the UIC programs to ensure compliance with the Safe Water Drinking Act. Second, the UIC can also grant primacy, which is primary authority to oversee injection well operations to a state, territory, or tribal agency if they can demonstrate adherence to the SWDA. So it's a big realm. The UIC establishes who has primacy and who doesn't, and it's based on their ability to uphold the Safe Water Drinking Act. The next slide just shows you kind of where Florida sits. 2012, they did not have primacy from the UIC to operate their own injection well programs, but just recently they were granted and approved primacy. So Florida has done a good job in adding another layer of protection in the regulatory realm with the Aquifer Protection Program. So injection well operators have to answer to them as well as the state Department of Environmental Protection. So it's beneficial to add layers to the system because it just helps with compliance and oversight. The point I'm trying to get across in this slide is with my planning background, what I've realized is that everything related to public policy has a goal, objective, and policy associated with it. The broad goal of the UIC and the EPA and any regulatory body overseeing injection wells is, of course, to protect your drinking water source. That's what everyone's focused on. That's what the laws that govern this are all catered to. The objective being 100% compliance. It's a measurable objective set forth in the permits, and all the policies that I will going forward refer to as safeguards are established in the permitting process, and they're enforced throughout the life of the well. So as we progress through this presentation, the safeguards are what we're going to focus on. Those are all outlined in the permitting. So I want you to understand that before an injection well is drilled, there's a cumbersome process that operators have to go through to get that permit approved, and it all ties back into the regulatory bodies that govern injection wells. So I broke these down into categories. These are my words, my interpretation of the different categories associated with safeguards as they relate to developing an injection well system. You've got geological, well construction, operational, monitoring, and closure. We'll go through all of these. I would say the first two are the most important because that's where your biggest associated risks are, which are migration of injected fluid into the USDW. And the USDW is the underground source of drinking water. That's clearly defined whenever you go to permit an injection well. That's something that they require you to define and find the bottom of the USDW. So on the geological side of the equation, I think this is the most important aspect. It's all outlined in the permitting process. There's a lot more to it than what I'm going to go over, but I picked a few critical sections that I think are really important to have at least a foundational understanding for. So what we're looking at here is your injection zone and your confining zone. Your confining zone, preferably you'll have an upper and lower, although the UIC does not stipulate that you have to have a lower confining zone if the well is deep enough. So Piney Point is a 3,000 foot well approximately, and it has a confining zone above the injection zone. One of the characteristics of a confining zone that has to be true is that it is low permeability and low porosity. So these X's represent you do not want fluid migrating up through your confining zone, because then you'll have penetration into the aquifer, and that's where you have your environmental catastrophe. So pictured here is also a monitoring well. Those are equally as important because those are continuously monitoring the water quality of the aquifer during injection well operations. So if you do have an event where you have migration of fluid, you will know it because the aquifer will be contaminated. The monitoring well has to be within 150 feet of the injection well. So that's an important aspect of it. That's close enough to have an issue. If you have an issue on surface, you'll know about it right away. So I found this doing some research. This was a graphic that I pulled from a local news report, and I found it misleading because the last slide we just showed, it's clearly there's a defined confining zone related to this injection well. And this graphic is suggesting that the confining zone is going to somehow allow fluid to migrate to the surface. We know that that's not going to happen because we know that the confining zone is confirmed when you drill the well. And we'll go through that on some of the next slides. So another important safeguard as it relates to the geographical section or portion of this is the area of review. This is critical because there are, believe it or not, well bores everywhere. Some of them are shallow water wells. Others are older injection wells that have been plugged and abandoned. So it's crucial to examine wells nearby and determine if they have the potential to communicate with the injection well that's going to be in operation. So for instance, if there's a well an eighth of a mile from Piney Point that goes 3,000 feet, you're going to have to do extensive analysis on that well to make sure that if it's in operation, there's no potential for it to communicate with the Piney Point well. Typically, the UIC does not allow 2 injection wells within a quarter mile, which is a great practice, but this is a very important aspect. This graphic shows you the actual FDEP application for Piney Point. And as you can see, there's a number of wells in the geological area of review. And to my knowledge, none of them penetrate the injection zone. They're just primarily water wells or irrigation wells. So in that regard, I believe there's adequate protection within the area of review standards. So moving on to the well construction aspect, this is where the bulk of my knowledge sits for the most part. What we're looking at on this slide is subsurface configuration. So there's a lot to kind of digest here. Kind of the high level takeaway is the configuration of the injection well. It's designed with multiple layers of protection. That includes pipe, which is referred to as casing in the industry, not to confuse you. And then you've got cement that surrounds that pipe. So when you're drilling an injection well, you have multiple stages that you go through. The first stage of drilling a well is called drilling surface. What you're doing is you're drilling down to this base of the USDW, which is, again, the underground source of drinking water. And you get down there, you're testing the water quality, you're getting a baseline measurement. And then once you submit to the state what your baselines are, you're allowed to set surface casing, which is this little skinny line here. And just not to confuse you, but this is a concentric view. So, I mean, you've got 6 layers, not including these top 2, that run through your USDW that are protecting that from fluid migration.
Okay.
So as you go and you set casing, you're pumping cement down the pipe, and then it's circulating up the hole, and it's creating a stabilization for that pipe. And it's extremely important that your cement is pumped properly. And because of that, the UIC requires logging to confirm the integrity. So to give you an idea of how that works, this is the baseline technical data. Your cement bond log, CBL in short, is a sonic tool. It provides a 360-degree interpretation of the quality of cement bond to the casing's outside diameter. Or I'm sorry, the outside diameter. The sonic waves are going to look different for casing, cement, and formation. So it's easy to discern if you have an issue downhole. So in the event that you come back with a log and you find that your cement is not properly sealed or there's not enough cement in an area, there is a way to remedy a poor cement job. However, it's way too technical to get into how, because it involves a very intense operation that's extremely costly. So everyone who drills an injection well focuses on cement, and they spend a pretty penny doing it. So it's really important to understand the layers of protection that are included in an injection well. This slide is, in my opinion, this is the most important tool with regards to drilling and operating an injection well. It's called the isolation packer. I say that it's important because the isolation packer prevents fluid from migrating up the pipe. So this is a different schematic than the one we just looked at. I simplified it to make it a little easier to understand the concept, but basically you've got your layers of pipe surrounding your final layer of pipe, which is your injection casing, which is where all your fluid is being injected. At the bottom of that sits your packer. These red X's indicate the isolation effect you get from the packer, which protects your annulus. The annulus is simply, just picture sliding a 2-inch pipe or inside a 4-inch pipe. It's the space in between. So there's a void there. So 1, you have to isolate that void. And 2, as part of the process to protect the well, you pump a fluid, which is obviously termed packer fluid, down the well in the annulus. And what that does is it prevents corrosion, and it also provides a marker for leaks. So that fluid, the characteristics of that fluid are such that when you sample it on surface, so there's a gauge, an outlet for sampling packer fluid, and you're required to do it as part of your operating permit. And you do that because you want to see if there's any salt in that fluid. If there's salt in the fluid, you have a problem. You have a leak either in your packer, you have a leak in your casing, and you have to remedy it as soon as you find out. I won't get too much into the packer assembly. I just really like these tools, so I wanted to show you kind of how they work. The main mechanism is your seal assembly there in the middle. And the way that a packer is set down hole is typically, there's a few ways to do it. The primary way that I've seen it done is run through what's called wire line, which is basically a long, I'll call it a string, but it's a metal rope essentially, and they put the packer on the end of it. They get it down hole where they want it, and they turn it. And in turning it, it sets the slips with compression, and it seals to the well, and you're effectively isolating the annulus. So I can't stress how important this tool is, because if you don't have this tool and you have fluid in the annulus, it's going to corrode your pipe, and then you have integrity issues. And at that point, the well is ruined, and you either have to plug and abandon it or drill a new well. The last section for well construction standards, this one I feel is kind of important. You've got a step rate test. So I've conducted a lot of these in my career. We use them to ensure that the injection zone is suitable and also to size the pumps for injecting water. So the way it works, it's just a linear relationship between pressure and volume. So you start off at a low pressure and a low volume, and the goal is to ramp up to your max permitted pressure. These are nominal numbers here. They don't relate to anything Piney Point, but I do know that Piney Point's maximum injection volume is 95,000 barrels per day, which even in my world is a ton of water. So the goal here, I also know that the lower Florida aquifer is going to be very low pressure, very permeable and porous. So there should not be high pressure associated with injection. But in the event that your step rate test shows that you cannot operate that injection well at the desired volume and you're overpressured, they will not approve the well for operation. Another important aspect is confirming porosity of the injection zone, because a lot of the times they call it wildcatting in Texas, where you drill a well and you don't really know what you're getting. So when you're wildcatting, you can drill an injection well without a permit, but you can't operate it without that permit approved. So part of that approval process is submitting what's called a combo log to the state. Getting into the technical terms, you've got neutron porosity and density log. So you can't measure porosity based on one logging technique. You have to use a combo log to satisfy the state's requirement for suitable porosity in that zone. So this is just a really technical tool that aids in establishing the baseline porosity for an injection zone. And this is the one for Piney Point, and they did prove that it was a suitable injection zone, to my knowledge. Last couple sections here. Pardon that. I'll kind of get through these quickly. The operational components, this is basically what you have on surface. The wellhead is a very important aspect of a disposal well. That's where all your fluid gets shoved down hole. So you'll see in the picture, you've got a high pressure injection line that's going to carry your fluid down hole. The top of that assembly is nicknamed a tree, because you can see it kind of has branches. On those branches, you're going to have pressure gauges that monitor pressure on or downhole pressure at all times. And then redundant master valves, which is important. If you ever need to shut the well in, you want to have two valves in case one gets stuck or one doesn't work. The B section and the A section, not to confuse you and go back into slides, but if you'll remember, I talked about the different casings in the well. The B section is associated with the intermediate casing, and the A section is associated with the surface casing. Why it is important to have these gauges and be able to take measurements on surface is because if you ever have pressure on your B section, you know there's a problem. You know there's communication, because you should not have pressure on your B section. Same goes for the A section. If you have pressure on your surface, you might as well shut in the well, because that means you're getting communication with the underground source of drinking water, and that's a definite catastrophe. So in my experience in the last 12 years, we have never had a well that has received pressure on the A section. We have on the B section, and those are typically easier to remedy. You really can't remedy pressure on the surface casing. On the surface side, so we talked about the well, talked about some of the surface equipment. You also have a facility that you have to house this water before injecting it and treat it in some instances. I know for a fact that Piney Point has a treatment program associated with the injection well operation. So most of these safeguards are aimed at preventing spills on surface. A lot of the ones that we implement in Texas that are pretty standard are fail-safes involving tank sensors that will shut off your pumps to prevent overflow and leaks. And then the second fail-safe, that extra added line of defense, is an impermeable containment. So let's say your tank sensor fails and you overflow, you've got your containment that is protecting your groundwater from contamination. So it's important. The UIC certainly puts some stringent requirements for surface facilities, and they monitor them regularly. Regarding the monitoring, I didn't go too much into detail on this. What I will say about the monitoring aspect for injection wells is that it is very, in my opinion, I don't know if aggressive is the right word. I think it's suitable. Florida does it a lot better than Texas. I'll say that. These requirements, they have continuous daily, monthly, quarterly, and yearly. They're laid out here. I encourage you to look up the Piney Point permit and look through some of these, but this is a very thorough monitoring program. So one of the most important things you monitor is injection pressure and volume continuously, because your injection pressure is going to tell you when you have issues before anything will. So they require these to be submitted to maintain good standing with the state. So if you miss a reporting deadline, there's no extension. You have to shut down until you gather the data. Most of this on Piney Point will be acquired through remote monitoring, which is great because there's no gap in manual samples. There's no lag. Everything is manually, remotely monitored and recorded. Coming up on the last slide here, this is important in that you want to make sure the integrity of the well is maintained throughout the life of the well. So what the state requires from any injection well operator is a surety bond. They call it other things in other states, but it's basically proof that you're maintaining enough funding to close the well in the event that you need to plug and abandon it. So reading through the Piney Point documents, they've accounted for this, I think, adequately. They've estimated correctly on the cost to close a well, and they actually went a step ahead and proposed a date for closure based on the amount of water on surface that they have to pump down hole. Now, whether the state holds them to that date is to be determined. It's not a requirement to have a plugging date, but we know that the state, or we know that the county who's going to be operating the well has financial assurance to properly plug and abandon the well, decommission it, so to speak. So those are the important safeguards associated with injection wells. I'd love to hear some questions because there's a lot more to it, and I'm sure a lot of curiosity on your end.
And I don't know how you want to do it. Do you want to do it by putting it in chat and calling on people, or raising hands?
Yeah, Jess, if you stop sharing screen, we can see the people and then people can raise their hands.
Sure. There you go.
Ruth.
Obviously, we have a few questions.
Okay.
One of the things two things have concerned me about Piney Point, in that we have limestone as our stone by the aquifer, and also the fact that Piney Point has radioactive components, water. And I'm just curious to know if this deep injection well addresses it sufficiently that we don't have water seeping up through the karst, or that the water is radioactive and contaminate around it.
Yes, I'm definitely familiar with the karst geology in that area, all the sinkholes and the car dealerships that have gone into said sinkholes. What I would say is the confining zone is most likely not a lime. It might have a limestone component, but it's most likely a dolomite, a harder rock.
Okay.
Looking at the logs, it is not permeable. So you can tell on the electric logs that they ran that you're not going to have you're not going to have migration vertically. There's always a potential for fracturing of a confining zone,
Right.
but being sufficiently thick as it is in Piney Point, I think it's well protected from the confining zone. Now, if anything were to breach the confining zone or migrate up pipe, behind pipe, through failed cement or what have you, then yes, you'd have a problem. I think the key here in Florida is the monitoring well that they've drilled 150 feet away. That's really going to stop issues from becoming problems.
Okay.
To address the radioactive component, that's something I have a really good friend in the water treatment business that has worked tirelessly on Piney Point to try and get samples where he feels like there's a problem. And nuclear waste, not a joke. Radioactive waste needs to be handled properly. I think the lower levels of radioactivity that they're seeing from these gypsum stacks they're not concerned with. I don't know what type of level of treatment they'll have on surface to remedy that, but once it's in solution, it's hard to get radioactivity under control. So in Texas, it just gets injected downhole, and hope it never comes back. I mean, that's part of the confining zone. That's part of putting it into the injection zone that's permeable. But according to the state, they're not going to be injecting any radioactive fluid.
Interesting. Okay.
Anybody else?
Mary Lynn.
Who will be doing the enforcement of the safeguards in
It's a good
our
question.
Piney Point situation?
Yeah, so the state is the primary authority for enforcement, but you also have reporting going to the Aquifer Protection Program. So duly involved, they'll both enforce compliance and ensure that it's met on a daily basis.
And what level is the Aquifer Protection Program? Is that a federal level?
No, I believe that's a state program. I don't know if it falls under the DEP or if it's independent organization.
We just had with our current leadership at the state level, we've just had a very much gutted regulatory body. So the concern is no matter what the plan says and what the intention is, the reason we have Piney Point as a disaster area as it is because of lack of DEP action
You're absolutely right.
for years and years and years. So I don't have any confidence that this will be any more regulated or kept track of than what has happened that caused us to get to this point. So
Yeah, quite frankly, the biggest issue, in my opinion, with this injection well is going to be oversight, like you say.
and then the other,
Activist organizations can play a critical role in that. Demand compliance, I mean, it's public reporting, so all their quarterly submittals are going to be online and you can access them. So they can't really miss a submittal deadline. But you're right, that's definitely of consideration for sure.
and then the other goes along with the radioactive waste, but because we can't get any kind of sampling of what's actually in the water that they're going to be injecting, we can't be confident that there isn't something that, so I guess back it up. You said this particular type of well takes care of hazardous and non-hazardous waste. So even if it had hazardous waste, are you saying this well will not, if it's all done properly and all regulated properly, will not ever cause a problem?
So I might have misspoke, but this well is not permitted for hazardous waste. They're only permitted to inject non-hazardous, which is why the state has taken the position that there will be no hazardous waste injected.
Okay, so
The county
without
affirmed that.
sampling at various levels and various places and all those waters that they're planning to shoot down there, they're not sampling, or they're not giving evidence that they are sampling to know whether or not there's hazardous waste.
I know that they're on record with samples that they've acquired. Now, whether those are cherry picked or not, I mean, I've seen that game played, but
Yeah, we are pretty sure that what we've seen is just cherry picked. We can't get any support for actually having an independent sampling or other eyes helping with looking at the samples.
that's interesting. The silver lining there, I guess, would be when the well gets put into operation, they're going to have to submit sampling for fluids that are injected downhole, which will be representative. It can only, I mean, there's no getting around that. You can't cherry pick that sample. So
if at that point it's determined there's hazardous waste, is that too late, or is it
yeah, they'll shut it
at
down.
that point?
Is it too late? I mean, to an environmentalist, yes. But you have to assume that your aquifer is protected, but the state won't allow it. I mean, it's not permitted for a hazardous. They'd have to get an extension and an exemption. So they'd have to reapply for a permit, start the process over again. I doubt the county wants to do that. So I'm pretty sure their goal is to remediate any radioactivity on surface.
Yeah, you could be assured of that, but I'm not.
Yeah, it's radioactive waste. We deal with it every day in Texas, and it's ultimately buried underground. So I'd rather have it 9,000 feet below surface than right under my feet, but that's anecdotal. So
What other questions do we have?
Peggy had a question. And then
Okay.
Don.
Hi. I might not have been following this as closely as some of you. So I want to go back to some real basic questions. number one, when, do you know when Manatee County is, like, when this is all gonna be ready to get going, or is it already in place, some of it? And is the idea of this to remove all of that liquid that's in there and then shut it down and, oh, just broke
Oops.
something, and shut it down and then cover it all up? Is that the point, or is this something that's gonna kind of be ongoing?
I believe the calculations that were provided gave for about a 2.5-year time frame on this to answer that part.
To move all the liquid through, or?
Yeah, so there's something like 500 million gallons.
Wow.
They're going to be injecting 400 or 4 million gallons per day. So that's the lifespan of the well. And then I did mention the state does have a plan based on that calculation to plug and abandon the well, which at that point you have no issues with contamination because you're not increasing the pressure in the reservoir at all, or continuously
Okay.
increasing it, I should say.
Thank you. I gotta clean up. Gotta clean up my own mess.
Don, you had a question.
Yeah, am I unmuted? Yeah.
You're unmuted. We hear you.
Okay. I've seen a few, like, reading a little, seen a few pictures and different graphics about cracks developing. The problem with these injection wells is, and it might not be instantly when they're pumping, but over time they can develop cracks, and all that monitoring in there, in that small contained area around the pipe might not tell you. It's a risk worth the consequences of ruining drinking water for people in this part of the state. It seems so bizarre.
That's the crux of it. I
Mhm.
mean, the way I see it is, do you want the water on surface, or I don't see a better way to remediate this issue, quite honestly, because you have 500 million gallons of waste on surface. Right now, they're treating it intermittently. They're doing a very little volume per day. No one really knows what the effluent quality is, because like you said, there's a hurdle with the sampling and transparency in that realm. But injection wells are, and this is my opinion, inherently designed to be safe. You have multiple layers of protection. Of course, over time, if you're operating a well for 20 years continuously, you have the risk of corroded pipe and intrusion into the reservoir. But in this case, it's a relatively short-term operation that they're proposing. So if you were to do this and try to treat it on surface, it'd take something like 10 to 15 years with the throughput capacity that they have now.
Mhm. Thanks.
Sure. I want to share a document real quick because I just saw this as part of my research with regards to oversight. So the well's been drilled. I want to show you their inspection report. So they had someone from the county go out and actually inspect drilling to make sure that everything was copacetic. The location was clean, there was no pollution. And I can send this, you can send it out to the group. But I mean, they were taking pictures of, in my opinion, they were nitpicky, sacks on the ground that had a little cement that were on the ground. They really went into the details on this. And that was something that was refreshing to see. I mean, they don't do this in Texas. So I think it's a good step in the right direction for the DEP to have oversight already during this drilling process. I think a lot of that is because of the attention that it's getting from the public, but I really think that they're trying to put their best foot forward here and ensure that this will be done safely and also be effective. So I just wanted to share that with you.
And it's also because there's a pending lawsuit against them all.
Yeah, that helps expedite things.
Tim, you had your hand up before Jesse shared that screen.
Yeah, Jesse, you mentioned that they're injecting a ton of water. And I was wondering, you said your 12 years experience. Have you seen a comparable project to this one with the volume of water, the pressure, the depth? One of the reasons I ask, and any failures that have happened in a similar thing. The reason I ask, one of the reasons is I recently met a boat captain who worked on the Deepwater Horizon BP disaster for 3 years, both before and after the disaster happened. So, and I was impressed by how many things went wrong that contributed toward the failure, and then how much they've tremendously improved as a result of that disaster. So that's why I was wondering if you're familiar with any comparable situations in the history of both success and failure on that.
Sure, that's a great question. Lots of layers to that. So I'll touch on the BP side. That was a cementing failure, and the pipe collapsed because of it, and they didn't have the right controls on surface, technically underwater, to control the blowout disaster. It was trying to pinch a penny, and everyone learned their lesson there. So as far as in my experience, like I said, 95,000 barrels per day, I'm converting barrels to gallons because that's the world I live in. Relatively to me, that's a lot of water. My company's highest volume injection well is 25,000 barrels per day. Now the pressure on that well is 3,500 PSI, whereas the pressure on this well is going to be probably less than 1,000. I'm not sure because they're not pumping it yet. But the failures that I've seen, and I've seen 2 internally in my company, 2 well failures, have all been caused by a formation characteristic. So we were pumping into an old deep aquifer, brine aquifer. So we're not contaminating drinking water, but over time the zone pressured up and it forced cement to slough off the casing and corroded the casing, and fluid migrated up the annulus of the pipe. Also, subsequently, our packer failed. So it was just a plethora of issues. So I have seen failures. They've all been related to the formation. Typically, pipe has a lifespan of about, I'd say 40 to 50 years. But at that point, injection wells probably aren't going to be, this injection well certainly is not going to be in operation for more than 10 years. So I think the lifespan, the relatively short lifespan of this well is going to only help in mitigating the risk. Did that answer the full question? There was a lot in there.
So I think so.
But 95,000 barrels a day is a lot of water, I assure you.
I've got another question, unless somebody else has one first. This obviously is a specialty to be able to do a deep injection well. Are you familiar with the company that has been given the contract to do this? And have you had any experience with them?
So early on, when I heard about this, I was very involved with Dr. Pope and Emily Ball, I think were their names, Ball. I spoke with them just to kind of see what the situation was. I'm a water treatment nut, so I really wanted to better understand if they needed help in that area. As I said, I have some contacts in Florida that treat water for a living, so I really wanted to get engaged in it, and it was kind of an interesting dynamic because the county was going to operate the well, and that's rare to see that dynamic. So I was curious about how that was going to work. And as far as the deep injection, wait, I'm sorry, I lost my train of thought there. What was your question?
About the company, just the company.
Oh, yes. Okay. So in talking with those 2 individuals, I got a hold of AECom, which was the engineering firm in charge of designing some aspects of the well, the engineering part. So the packer, isolation packer, and the casing. But my understanding is the hands changed there, because if you look at the permit application that was previously submitted, it was submitted by a C2HM Hill, and AECom actually finished it. So directly answer your question, no, I don't have any experience with them. I could not get anyone on the phone to talk to me about the process, but my understanding was that the county contracted that out to whoever was willing to execute the project in entirety, and then ended up switching kind of in the middle of the process.
And that was Vanessa Baugh, Jess. She's the
I'm sorry, Vanessa Baugh, yeah.
commissioner.
But really all this hinges on the county, and the county being 100% compliant. So they have a vested interest in this, which is good. It's, you don't want this operated by a private company. I think it'd be a completely different story if there was a private company actually operating the well.
Hi, this is Randy. Do you have are there any ideas why that first company backed out?
No, I can make some assertions that I looked at their permit and it was terribly put together. Their due diligence was not great as compared to the permit submitted to the DEP recently. So I don't know, the process has really dragged out. I mean, I don't remember the date. This last permit I looked at was like 2012. So I've been trying to do this for a long time. But no, I don't have any insight into what happened there.
Any other questions?
Well, you're definitely providing some invaluable insight into how this all comes together. I'm going to ask you to make a general statement. I know you've made several general statements, but based on what you see and how this is designed to work, I think I heard you say that this is probably as good a remedy as we could hope for our difficult Piney Point situation and the contaminated water, better than going into the bay or rupturing or something like that. Am I correct? I don't want to misquote you.
No, that's my viewpoint. I think just looking at the situation holistically at a high level, the injection well makes the most sense.
Okay.
The longer that water is on surface, the worse the contamination is going to get and the more leaching you're going to have. And you guys get a lot of rain down there and that's a problem. So
Yeah.
put the water away.
Right. Well, let's hope away really does stay away and doesn't seep
Right.
through. And that's our biggest concern with the car system and the way our underground, you know, the whole aquifer system, it's just goes everywhere. And I think a lot of us have concerns because of that.
But let me just ask Jess, did I hear you say that the really with the way it's constructed and with the monitoring that's in place, that we really don't have to worry about the aquifer?
That's my
Yeah.
That's my viewpoint. Yes. You have so many safeguards in place just in constructing the well, and then in operating the well, you have layers of protection to ensure that there are no issues. And if there is an issue, it will be addressed immediately through monitoring and reporting. So stay on top of the monthly reports. Like I said, they're going to be public, and stay in front of the county. I mean, I'll be looking at them too, and I'll be sure to send you anything I see that's out of the norm.
Well, that we appreciate.
Could you clarify the timeline? How long before the well will be actually able to receive the water? In addition to how long will it take to move that much water?
The first part of your question, I'm not sure. I've been checking up on the progress. Some of the documents that they've uploaded, they're in a different format, so I can't open them, but it seems like the drilling is complete. As far as when they're going to inject it, that's probably going to be a little longer of a process to build the facility. I don't know how access is to that site, if you can drive down a road and see what they're doing, but in my industry, as soon as you start putting tanks up, you're about 3 weeks out from injecting water. That's typically the rule of thumb, but that obviously is not going to apply to this situation. It's going to be a lot different with the county running the project. So I'm not sure when that would start.
So the well has been drilled, basically.
Yes.
All those
Yes.
layers and the whole layering and all the safeguards are already now in the ground in place.
They're at the last stage of it, if anything. I'm not sure if they've set their final casing or their injection tubing, but you have to understand that even when the well is drilled and the casing is in the hole, there's still a lot of testing they have to do to confirm things and make sure that everything falls within the guidelines of the permit, like your pressures and your injection volume and the porosity of the zone that you're injecting fluid into. So the state will take some time to review those logs. Just a cursory review on my part, they looked really good as far as porosity goes. It looks like that's going to be a suitable formation for injecting that volume of fluid. Yeah, so it takes some time. There's a lot of also red tape in that process. Like you mentioned, there's not a whole lot of departmental oversight available right now. So yeah, that's another important, I can send this to you, Mom, but it's the Piney Point injection application where they had a public commentary, and there's probably 25, 30 questions that people asked that were fantastic questions. I think the state did a great job in addressing the questions. So they obviously have an in-house expert on staff. I mean, whoever was addressing the questions had a really deep knowledge of injection well operations. So I was pleased to see that.
Jesse, it's Randy again. I think I know what I want to ask. Having the county involved or sort of running the project, I think is what you had said, which is, I guess, sort of a unique situation for what you see in other areas. does that complicate better work, how does that relate to then dealing with, say, Florida DEP or up to the UIC and EPA? How is that relationship good, bad, or indifferent, do you think?
I mean, I moved away from Florida 12 years ago, but I interned with the Florida Department of Environmental Protection, actually their aquatic preservation department. So I will say they used to move slow. I don't know how that, I don't really know the dynamic because I haven't been, entrenched in that realm. So the county being able to operate the well safely, they have to operate within the bounds of the permit. So they really have no choice. It's going to be a matter of, surely they're going to contract operations out to a third party. And that's going to be where the reporting and the monitoring falls. So you're on the right track thinking along those lines. I don't really have a firm answer for your question, but you definitely have access to the county more than you would a private company, I would think, as far as beating down their doors.
Yeah, thanks. And so I don't know that the county employees have particular certifications in this, but they would presumably, I don't know if they have, farm it out to a third party or something like that, because I assume the county's not going to have the expertise to really manage the project.
Yeah, I would make that same assumption.
Okay.
They would have to hire a technical expert.
Yeah, but I don't know if I don't know if anybody on the call knows, but you would think they would, but I have no idea.
Well, that's a good question. I actually didn't see that question come up in that document, but that's a good one.
All right.
Jess, can you explain one more time, Mary Lynn's concern about the cherry picking of the water samples? You said at some juncture that won't be able to happen because of requirements. Say that part again.
Right. So as you're injecting fluid downhole, they require you to take a representative analysis of the fluid being injected through a port on the pipe going into the well. That's their stipulation. That's their requirement.
Okay.
So all the pipe going, the water being injected downhole, it's going to fluctuate. Water quality is going to fluctuate. All water quality fluctuates, but taking that sample and continuously monitoring that water, I think it's a weekly analysis that they have to submit. There's no cherry picking that because it's water being injected downhole. It's going to be the same relative quality.
Okay. And at any point, if they detect radioactivity, that well is not designed?
Correct.
Okay, so
They would have to cease operations.
Okay.
That's good to know. I think Judy had a question too. Judy?
Yeah, I'm a little bit foggy on that 110% of tanks. Is that where they're going to pre-treat the water? Is that for the pre-treated water before it is pumped down? 110% of what?
Of the storage capacity of the facility. So anything that's above ground holding fluid, whether it's treated or not, the containment has to be sized to compensate for 110% of that volume
Of
fluid stored above ground.
Yeah,
it has nothing to do with the well. It has to do with the surface, the storage on surface. So your tanks on surface.
Okay.
Oh, so that is just 110% of whatever they're putting into the tanks, which presumably would be after they do their dual treatment.
But
Well, you'll have tanks that are pre-treated. You'll have tanks that you'll flow water into that is not treated, and then you will flow to other tanks and treat in between. So regardless of the process, like if you have 1,000 gallons of above ground storage, then your containment needs to have a surface area that will contain 1,100 gallons.
But that's only for what they decide to store specifically in the tanks.
Correct, because you will only have that amount of water in the tanks at all times. It's your maximum capacity above ground.
Yeah, because I don't remember seeing that addressed at all when I went to the presentation that they gave, any kind of that. I don't remember seeing anything of that nature. They talked about about open treatment ponds, and they talked about pumping the water down. I do not remember any discussion of interim water containment on the site. I'm sure from what you say, it must be there, but I didn't see it in any of the plans at the thing they gave at the library, the presentation they gave at the library. And I didn't hear anybody address that prior to your bringing it up.
It's interesting. So I might have made a broad assumption here, but the UIC is the one who sets forth the 110% of your containment guideline. So I would assume it's in there somewhere in the permit, but it's probably, I don't know, might have been overlooked by them as far as presenting that to you all.
I don't know, because
I,
what they talked about were two open, you know, they're gonna do breakpoint chlorination to get rid of the nitrates in there. And they're gonna do phosphate settling to get rid of the excess sulfates, which is where they also think they're going to get rid of a lot of the radioactivity. And then it's the remaining water then that's going to be pumped in the well, according to what they said at the presentation. Now, you know, I'd like some of the people here, I'm sure, have been to many more things than I've been and read much more about it than I have. But I don't remember this tank thing. I don't remember seeing in the, I guess they'd have to put it in something before they pump it down the well, huh?
That was my assumption. Yeah, I don't know. I mean, they could be doing it a different way. I mean, every injection well that I've been involved in has had some type of above ground storage, and nobody likes to dig a hole in the ground and line it and put processed water. I mean, they already have that. That's what Piney Point is. It's just two big ponds that are lined with contaminated fluid. So
yeah, we're going to have a couple more ponds that are filled with supposedly won't be contaminated when they're done, but that's
that's interesting that you mentioned the chlorination process and dropping sulfates out. I wouldn't think that'd be a necessary process. The nitrogen, the phosphorus, and the sulfates are fine pumping them downhole. That's the whole reason for the well, because otherwise, what are you going to do with those solids when they're removed from the water? At that point, you're just pretty much injecting water that's a little bit dirty. You know, it's not that contaminated. So I would think that you're going to be more efficient getting rid of the waste if you keep certain things in there. Obviously, the radioactive component needs to be taken care of.
Well, I think that's probably part of what they're hoping to take out when they do the settling, but we'll see. I don't know.
Yeah, then you got to remediate that.
The other thing, breakpoint chlorination, I mean, you're putting all that nitrogen trichloride into the atmosphere, which nobody's addressed at all. But then again,
I think that's a contained process. I'm not sure how they're doing it, but yeah,
I'm not sure either. And the other thing is, you talk about the confining layer, but what about the fact that this water is going to be so much purer in certain respects than the water that's already in there? Isn't it going to start dissolving that confining layer?
No, you're saying less saline, so it would dissolve.
Less saline, lower TDS and higher pH than what's ambient there. I mean, you know, you can't, if you pumped rainwater down there, it'd start eating at the dolomite or the limestone or whatever there is there instantly, even though we don't really think of rainwater as being terribly polluted. It's a TDS issue.
Yeah, the thickness of the confining zone is what I would say. I mean, that requirement alone makes it a pretty sure bet that you're not going to have migration. I mean, 150 feet, even if it dissolves a layer of it, you know, a lithographic layer of 10 feet or so. I mean, you're not injecting enough fluid the lower Floridian aquifer is just a massive river. So, I mean, the amount of fluid you're injecting down seems like a lot, but it's really not as far as dissolving certain things downhole, because you
think it would be sufficiently diluted by the other high solid water down there so that it won't cause a large amount of damage to the confining layer above it. Is that what I hear you say?
Yes.
Good question, Judy.
These were great questions.
Yeah, really, very good.
I'm looking at the time, and
I am too. we've had a great turnout, and if there are more questions, I think I see something in chat here also. We don't want to miss anyone. Yeah, that's good. I think we are very fortunate to have Jesse take a look at this situation with his discerning eye and expertise. Thank you, Jesse.
Thanks, Peggy.
And thank you, Peggy, for saying that. That's a good statement. I think we all feel that way. Your expertise and your knowledge in this arena has been invaluable, because a lot of us, I hate to say it, have been very nervous and a little bit distrustful because of how the process has unfolded. And I feel a lot better. Am I 100% convinced? No, but I feel a lot better. And I hope others do as well.
And if we ever have any more questions, I know how to reach him.
Oh, good.
So thank you, Jess.
You
I
can
know,
run, but you can't hide.
I know he spent a lot of time on this, so I appreciate all the time you put into this, and I learned a lot.
Well, I'll end with this. And one of my favorite sayings I tell my CEO all the time is, when compliance fails, protection goes with it. So keep an eye on it. I mean,
Yeah.
talk to the county about it, try to find out if they're being cagey. There might be a reason. So, it's a safe process. It's designed to be safe, but when you don't apply the safeguards and continue to monitor things, it goes wrong. It can go wrong. So
But we have access to those monitoring reports, right?
you should, yes. I can
We
send you a
should.
link.
Yep.
Great.
Thank you very much.
Okay.
Thank you.
Really enjoyed it.
Yes.
And I
Thanks for the time.
appreciate everybody being on the call. We're here once a month on this, what is it, second Tuesday of the month. So you're welcome to come back for additional meetings. Next month, we will have someone from the Florida Department of Agriculture speak with us, and we will try to give you more information beforehand to let you know who it is and specifically what will be discussed. But again, thank you everyone for coming. Any closing words?
Thank you,
Barbara?
Jesse. Thank you, Jesse.
Thanks.
Thanks, everyone.
Good
Thank
night,
you very
everyone.
much.
Thank you.
Great.
Really
Bye.
appreciate it.